And so the fifth way we can go about computing limits algebraically is by recognizing trig limits that we love. So essentially, these are trig limits, so I'll write trig limits, that you need to memorize. And they go like this. The first is that the limit as x approaches 0 of sine x over x, this is always going to be equal to 1. So let's say we have to take the limit as x approaches 0 of the function sine 4x over 4x. This is going to be equal to 1. If we take the limit as x approaches 0 of sine times negative 3x divided by negative 3x, this is going to be equal to 1. And so the point is if we are taking the limit as x approaches 0 of sine of something in that box divided by that same thing, this is going to be equal to 1. The second identity is that the limit as x approaches 0 of 1 minus cosine of x over x, this is always going to be equal to 0. So if I have the limit as x approaches 0 of 1 minus cosine of 3x divided by 3x, this is going to be equal to 0. If I have the limit as x approaches 0 of 1 minus cosine of negative 10x divided by 10x, this is also going to be equal to 0. And so you might be seeing a pattern here. If we take the limit as x approaches 0 of any function, 1 minus cosine times something in a box, divided by that same thing in the box, we get that this is equal to 0. And so the critical thing to note is that this only works when you're taking the limit as x approaches 0. Here you can see that we're always taking the limit as x approaches 0. If we have a function where the limit is, say, x approaches 7 of sine x over x, this is not equal to 1. Similarly, if we have the limit of x approaching maybe negative 3 of our function 1 minus cosine x over x, this is also not equal to 0. Why? Because we are taking the limit as x approaches 7, not x approaches 0. So how might we actually use this? I'm going to scroll down here for a second. What we can do is we can simplify equations so they end up looking like this function. For example, let's say that I need to take the limit as x approaches 0 of the function sine x over 3x. This simplifies to the limit as x approaches 0 of 1 over 3 times sine x over x. And I can go ahead and bring this out to the front because it's a constant. So this is equal to 1 over 3 times the limit as x approaches 0 of sine x over x. We love this because we know that this is equal to 1. And so this would be equal to 1/3. Let's do another example. Let's say that I need to take the limit as x approaches 0 of the function sine 3x over x. What I can do is I can multiply the top and the bottom by 3. And then I can go ahead and bring this 3 out into the front as a constant. And so this simplifies to 3 times the limit as x approaches 0 of sine 3x over 3 times x. Again, recognizing that we love this because we know that this is equal to 1. And so we would say that this is equal to simply 3. Let's do one more example. Let's say that we're asked to take the limit as x approaches 0 of sine 3x over 5x. Well, first I'm going to rewrite this as the limit as x approaches 0 of 1 over 5 times sine 3x over x. I'll go ahead and pull this 1 over 5 out to the front because it's a constant. So I have this is equal to 1 over 5 times the limit as x approaches 0 of sine 3x over x. I'm going to multiply the top and the bottom by 3, and then I will pull the 3 out to the front because it's a constant, which gives me that this is equal to 3 divided by 5 times the limit as x approaches 0 of sine 3x over 3 times x. And now here we have the limit as x approaches 0 of sine 3x over 3x, which we know is equal to 1. And so we would say that this is equal to simply 3 over 5.